assignment, so Jane could explain through the documents and files, etc. There's a map and a lot of diagrams as well. Yes. So see that as a group in the afternoon sections, and then Jane will explain the assignment. Okay? Good. Well done. So thank you, and
Okay.
I'm going now.
That's fine.
Yeah.
Does Gary know which room we're in? He'll just turn up, will he?
I would email him again
Right.
today. I think he probably knows where, but probably not know the building.
Yeah. Well, yeah, I'm sure he'll find it.
Yeah.
No. Right.
It's a
Okay.
bit tricky, this building.
Yeah, I'll be here anyway.
Yeah. Thank you very much.
Okay.
Bye.
Right. Good morning, everyone. We'll make a start. You're going to be sick of me by the end of today because, unfortunately, I think you've got me all day, just about. I'm going to go through a lecture on pipeline surveillance first. Then I'm going to look at operations and maintenance. I've already had a question about exam questions. Everything I'm going to do this morning is covered in an exam question. Well, not everything, but the topics are covered on an exam question. I'll try and point out to you important features as we go through. I have got a couple of tutorial questions which, if we've got time, I'll give you some opportunity to think about, just simply because it's good experience to think about questions asked about the subject matter. Okay, so that's this morning. Then this afternoon, the first session, which starts at 2 o'clock, I'm going to take you through the assignment that I want you to do, which, as Narracorn has told you, all of the documents are on Blackboard. Two of the documents, one is a pipeline map, route map, and the other is basically the map combined with aerial photography, or doctored aerial photography. And you really need to be able to look at those, so it's much easier for you to have a screen, because they are high quality documents, so you should be able to home in and to essentially blow them up. If you look at hard copies of them, then they're not terribly easy to look at. Okay. Also, I've included a section of one of the pipeline code that I want you to read. There is another pipeline code you'll need to make reference to, but you'll get access to that through the library. Okay, so if you could make sure that you've got those documents this afternoon, it will make the introductory session much easier. Okay, then at 3:30, Gary Anderson from TDW is coming to talk about hot tap and stoppling activities. I'll pick that up again next week, because there are aspects of it that you need to be able to deal with in the exam. Gary is the expert, and he will give you an excellent lecture this afternoon, and I'll just pick up next week as part of the emergency operations which aspects that you need to consider, that you're going to have to refer back to Blackboard and look at the notes that I will put on Blackboard for you. It's okay. So after today, I've got a session with you next Friday morning, which we'll look at emergency operations, and also we'll continue the assignment. And in terms of that, the issue, hopefully you'll have had a chance to look at the assignment, and if you've got any questions or queries you want to raise with me, then I'll be here at that session. Okay, and then that essentially completes my input to your course. Right, okay, so I'm going to go through pipeline surveillance. Now, one thing I would like you to pay attention to in this lecture is, why do you do pipeline surveillance? How do you do it? and what information do you pick up. And it's when you see some of the photographs I'm going to show you, you'll see very clearly what information you can get and what information you can't get. I've had some amazing responses to exam questions where people have told me that with surveillance you can pick up defects on the pipeline and you can assess loss of wall thickness and things like that. Now, obviously that isn't very accurate. Right. I'm going to concentrate on traditional surveillance methods. There are new surveillance methods, obviously satellite surveillance, etc., that can be used and are used in some remote parts of the world. However, everybody keeps coming back to the traditional techniques, so that's what we're going to concentrate on. Okay. So while we can mention satellite photography, that's not really what I want to concentrate on in this part of the course. I am going to cover imaging technology because if there is a specific issue associated with a pipeline, operators will often use imaging technology to get more information and to allow more detailed analysis. And then obviously, depending on how you deal with all of this information, you can pull it all into an integrity management database. Okay, so this is what I have to find, but this isn't going to work properly. You're supposed to be seeing a photograph of a helicopter and a fixed wing aircraft, which you're not. Right, if this lecture isn't going to work properly, I might need to transfer to the PC. Anyway, traditional surveillance, the key things you need to remember are, because pipelines tend to be remote, and certainly remote from the operating centre, aerial surveillance is often the preferred route, just simply because you can pick up so much information quickly. However, walking or vantage point surveys are still important, so please remember that that those techniques are used as well. Right, now this is the information. This is why you carry out surveillance, and this is the information that you can pick up. If you refer to the notes as well on Blackboard, there's all sorts of information you can pick up through surveillance, but you will only pick up information which is available on the surface of the ground, right? You won't be picking up anything about the actual pipeline itself at its buried depth. So the purpose of doing it, there's two main reasons for carrying out surveillance. The main one would be to look at any activities or events on the pipeline route which could pose a threat to the pipeline. In particular, any building activities or land management, any big activities such as quarrying or mining, and then what you're also interested in is what's going on around the pipeline. In particular, any people who are around the pipeline who obviously would become casualties in the event of an accident. And the key thing there would be it's fairly easy to monitor and keep track of fixed buildings. Temporary sites can cause a bit of a problem. And then obviously we're interested in events such as ground movement or flooding, which can certainly apply significant loading to the pipeline. Okay, so the going back to the purpose of surveillance, the other key requirement, there's a bit of overlap on these slides, but what you need to do is monitor developments that go on around the pipeline, particularly any developments which involve occupied buildings, because that's going to mean people are going to be there in the vicinity of the pipeline, and in the event of an accident they are going to be subject to hazards. So where are people around the pipeline, and what are they doing, and are they doing anything which could actually damage the pipeline and therefore introduce the threat of failure, and in particular they would be land management or construction activities. And then, as we said, looking at environmental issues. Right, in order to survey the route of the pipeline, you've got to know where the pipeline is, and that is achieved by using pipeline markers. And there are generally two sets of markers associated with any pipeline route. The first set would be aerial markers, which have got to be visible from the ground and from the air. Typically they would be about, say, 2 meters in height, generally spaced at around 1 kilometer, but they will be located so that you can pick up the route of the pipeline, in particular so that if anybody who's flying the pipeline can pick it up. So really they've got to mark as accurately as possible any changes in direction of the pipeline route. The markers have got to include the operator contact details. Now obviously that's not going to be visible from the air, but it will be visible from the ground. The other marker would be a boundary marker, which is smaller, and the purpose of the boundary marker is really to provide any information to anybody who might be legitimately working at that area. So typically you would have them at road crossings, rail crossings, anywhere where there might be other activities going on. Right, so this is typical of the kind of information you get from aerial surveillance. This is actually an aerial photograph that I've been using on a piece of work quite recently, and I don't know how easily you can see it. The pipeline is marked in red on that, and I was particularly using this photograph to identify where the developments, the buildings were associated with the pipeline, so that we could consider, are the risks tolerable? I'll be coming on to that in a minute. So as you can see, you do get a lot of information, you do get a very good impression of what's going on, but if you need any more detail, you're going to have to home in and get much closer. Another technique I'm going to talk about, which is used, being used much more commonly now. This was actually taken from a helicopter, but there is a system in more common use now where operators are using drones to actually survey the pipeline route, and this typically is the kind of output you get from there. So this is showing the pipeline route, which is used to actually, if you like, set the path that the drone is taking. Then you can see the proximity distance marked on the pipeline, and also you can see the hazard distance. That's the maximum hazard distance. So basically everything which is in the maximum hazard distance needs to be identified and checked to see if it's compliant. One thing that's important here is the pipeline will be designed to accommodate whether it's in a rural area or whether it's in a suburban area. So for example, you can see here, the sections of this pipeline you would definitely say are in a suburban area, so the design factor will be 0.3, which means it will have a much thicker wall, which means that the proximity distance at that location is going to be much smaller. Here you can see this looks very much like a rural area, there's nothing there. However, what's being plotted, this is the automatic drone system. This is plotting the standard rural proximity distance and hazard distance associated with the pipeline. It's not taking into account at all the wall thickness of the pipeline, because it doesn't know what the wall thickness of the pipeline is. So in reality, when you get results like this, you have to go through and check what is the wall thickness, and are these distances real, or could the distance associated with the pipeline be much smaller? Right, now let's hope this slide works. If the aerial surveillance picks up any information, there will be a need for the operator to do something in response to that information, depending what it is. Now, this particular slide is showing that the aerial surveillance has picked up drilling and boring activities close to the pipeline route. They were being carried out for the installation of a wind turbine site, but they were very close to the pipeline, so the operator had to actually go and visit the site and make sure that the activities weren't going to damage the pipeline. This is typical of what picks up, but here the walking survey, well, this could have been picked up by the aerial survey. In fact, this was picked up on the walking survey, and you can see the landowner has dumped material over the pipeline route. Similarly there, you can see that there's material just dumped over the pipeline route, which is indicating activities are going on, and essentially the agreement with the landowner would say you don't do anything over the way lead of the pipeline. You keep it clear so that it can be viewed from the air, and any issues can be picked up.
One question. So the landowner doesn't see the markers?
Oh yes, the landowner, basically the landowner will see the markers on their land, which will be agreed with the landowner when the pipeline is first constructed. And they also, in accordance with the standards, they should receive regular correspondence from the pipeline operator, reminding them where the pipeline is and asking them to inform the pipeline operator if they're going to be doing anything over the way lead. Now, landowners often don't do that, and what actually happens, we talked in the safety lecture about pipelines being long life assets, right? What happens is the land or the tenancy of the land changes during the life of the pipeline, and the landowner takes the view, it's my land, you've got no right to do this, and they'll actually move the pipeline markers, and they will ignore the fact that the pipeline's there. And you can see on this particular photograph there's actually a structure being built over, it's an aerial actually, but the landowner has allowed the building of an aerial right over the pipeline, which is in contradiction to the way leave that's been agreed. But the bottom line is that if anything happens, if the pipeline gets damaged and if it fails, the risk to people and any damage that's caused will be the responsibility of the operator. So the operator's got no choice. You've got to go and look for these things, and then you've got to deal with them if you find them. Now here's an example of this. This is an example which I actually received from an operator a couple of years ago for a particular training course. And basically what this is saying is, well, aerial survey actually picked up that drainage activities were being carried out very close to the pipeline. And that actually meant the pipeline operator had to go and investigate what was being done. These photographs were taken by the pipeline operator when they actually visited the site of the work. The drainage contractor had not been informed that there was a pipeline there, so they didn't know they were in the likelihood of causing damage. And in fact, they had caused damage. The operator took the view, you've been working over the pipeline, so we now have to investigate properly. So you must remember this, there are responsibilities for additional activities that have got to be followed up after the surveillance, and this is typical. The operator goes, they've got to immediately decide, do we need to investigate this site any further?
So, in terms of the operator, who's the person who actually goes from the operator side?
That'll depend on who the operator sends. Most operators will have operations and integrity management personnel, and they'll send them to do that. They may, if the operator hasn't got any staff in that location, they'll have to get some sort of land agent or contractor to go and do it for them. So for this particular example, the pipeline was excavated over where the work had been carried out, and you can see here that the pipeline had been damaged. And the damage was, again, it's typical third-party interference damage. You can see the gouges on the pipeline that have been caused by the drainage machine. And this particular incident did require a repair. So the need to carry out the repair has got to be assessed and actioned by the operator. Right, there's just a few slides here to show you that the aerial surveillance is often used by operators for other purposes. This is actually surveillance of the route of a pipeline during the construction and installation of the pipeline. So you can see, obviously, aerial surveillance does give a lot of information, and what they're doing is recording how the contractor is carrying out the sequence of activities. So in this one, obviously the route has been reinstated, and here you can see the final stages of reinstatement, and that route then needs to be monitored to make sure that the land does recover properly, because in most cases the land will be agricultural, and obviously the landowner needs to know that the land is going to recover properly. Now, this is a very old photograph, but it does show that this was taken about 2 years after the installation of a pipeline, and you can still quite clearly see the route of the pipeline. So the land is in the process of recovering. It's important that the operator monitors that, because if the land doesn't recover properly, or if there's a problem with the way the pipeline has been installed, the main issue will be drainage. The land won't drain properly, and as soon as that happens, the landowner will go in and start carrying out drainage activities, and that's what you can see going on here. And in fact, this particular photograph shows this is the landowner picked up by surveillance. This is the landowner doing some serious work to address what they see as serious drainage problems right over the pipeline. So obviously the landowner has got to do something to manage the land, but the operator has got to make sure that the pipeline doesn't get damaged in the process, and really needs to take a lot of notice of what's going on here, because there'll be a claim for compensation coming in at some point. Right, other typical reports that you might get back from aerial surveillance: if the pipeline has been subject to any sort of subsidence or ground movement, it will probably have been excavated so that the loading is removed from the pipeline. This particular pipeline section had been subject to subsidence due to mining. So it had been excavated, and once it's excavated and it's visible and accessible, the requirements for surveillance are more onerous, because obviously you need to make sure that no other activities are going to damage the pipeline. This shows you how powerful aerial surveillance will be for ground movement. The pipeline route is marked here, and as you can see, there is evidence of ground movement in the vicinity of the pipeline. Similarly here, the pipeline route is shown there, and you can see that an area of land movement has been identified, and they're starting to monitor exactly what the land is doing, so that they can decide when they have to go in and excavate the pipeline. we showed this, we looked at this example briefly in the safety lecture. This is the example of where the landowner was creating a large landfill site on one side of the pipeline and moving all the soil to the other side. The soil then slipped and took the pipeline with it. And that was the basically the situation. Once the situation had been stabilised, that was the state the pipeline was left in to operate over the winter before repairs could be carried out. Now, I mentioned earlier that one of the key issues for surveillance is monitoring developments around the pipeline. This is actually quite important, and this has got a strong link with the work you'll be doing in the quantified risk lectures. The issues are pipelines are laid on third-party land, and so developments can occur in the vicinity of the pipeline. Any developments could infringe the pipeline routing criteria which are specified by the pipeline code. This is the issue: are you in a rural area, so can you operate up to a design factor of 0.72, or are you in a suburban area, which means your design factor has to be limited to 0.3. Now, in the UK, those issues are now caught in a process operated by the Health and Safety Executive, where the pipeline operator has to notify exactly what the design is and therefore what the proximity distance is, and the Health and Safety Executive then notify the local authority, or in other areas it would be the local government authority, and basically say, if you get any planning developments in this zone, you've got to assess them, and HSE will probably object to them because they're going to contravene these things. Sometimes the process works, sometimes it doesn't. And where a land use planning system like that isn't in place, the onus is on the operator to check whether any developments have infringed the routing criteria. You've then got to do a risk assessment to check that the risk levels posed, and you're talking about the risk levels which are posed to the people associated with the developments. So where the developments are with respect to the pipeline is important. So if the pipeline is properly designed in accordance with codes which should align properly with the land use planning requirements, in most cases the risk levels should be broadly acceptable. However, where you get a situation where high populations are exposed to the risk, societal risk becomes very important. And in fact, most pipeline risk issues are societal risk issues, not individual risk issues, because the concern is that you're looking at a low probability accident, but if it's low probability, but if it does occur, you're likely to have numbers of casualties or fatalities. So that requires risk assessment and a LARP assessment. Okay, so I think we went through these examples at the safety lecture, but basically this is the routing process that you would apply when you're installing the pipeline. So you're looking for population densities, and then you're applying design criteria according to what you've found. So if the population density is low, you've got an R or a class 1 area pipeline. Where you've got a road crossing or where you've got proximity to developments, you've got an S area or a class 2 pipeline, which means that the design factor has got to be reduced to 0.3. Then during the life of the pipeline you could get additional developments occurring, so the pipeline's no longer code compliant. People could be subject to unacceptable risk. So you've got, I'm talking about a TD1 survey because the requirements for gas pipelines in the UK are specified by the TD1 standard, and that goes into a great deal of detail about how you do the survey. And so you basically, you've got to assess the development, you've got to do risk analysis and carry out any risk reduction measures which are required. So, as we said, pipeline infringements require a quantified societal risk assessment. The QRA studies carried out to assess the frequency of various harmful events, mixtures of leaks, ruptures, etc., which could cause casualties within the pipeline hazard zone. Remember, the hazard zone depends upon the diameter and pressure of the pipeline. Each event will have its own frequency and will cause a different number of casualties. In other words, the frequency of small leaks, large leaks and ruptures are all going to be different. The hazard zones associated with each are going to be different. The hazard zone is then going to capture people in the vicinity. So all of those are going to be, you've got to do all of those calculations and basically construct the site-specific event curve so that you can compare that to a criterion. And the key thing to remember is the risk is dependent on the proximity to the pipeline. Closer the population is with respect to the pipeline, the higher risk. And the area classification, which is based on the population density and which will control the design of the pipeline, in particular the design factor and the wall thickness. A summary of those two slides is quite important. Okay. Right. Now this is actually how essentially the process would unfold. If you identified something that you would then need to do a risk assessment of, the first thing you would do is plot out, this is a very simple example, plot out the route of the pipeline and then where aerial surveillance has picked up a number of developments in the vicinity, and you can see here they've been categorized in various different ways. Housing estates, villages, housing, that's all to do with residential populations. Industrial estates, shopping precincts, that's all to do with commercial and leisure interests. So you could have large numbers of people there, but the locations are probably controlled, and people aren't living there. They're not going to be there all of the time. Caravan parks are every pipeline operator's nightmare because caravans do not provide any protection to people in the event of an accident, and obviously they're highly mobile, so they can appear anywhere. Right. So on one particular, you've then got to go through each of these locations and carry out the risk assessment. This particular example is looking at one of the industrial estates. So you've got to plot the pipeline. Now I'm going to talk a bit later in this lecture, I'm going to talk about using virtual globes like Google Earth. This is a typical example of using Google Earth. So you plot the pipeline route onto the ground surface, and then you start mapping out different sections of the pipeline, because you're going to have to count people in each of these, and you're going to have to estimate the population density, and you need to plot the hazard distance associated with the pipeline in the event of an accident. And basically that then breaks up the population associated with the pipeline into discrete sections that you can go in and count reasonably accurately. You've got to assess the buildings quite carefully. Again, all of these images are taken from Google Earth, and you've got to come up with a logic as to how you're going to assess the number of people there. There are a number of standard rules that you can use. You could actually go and approach the building and ask the management what's going on here and how many people are there. That's the best way of raising concerns and getting people worried. So you probably wouldn't do that. So you've got to try and estimate what sort of numbers of people could be involved, and then you've got to consider when are people going to be there? Are they going to be there all the time? Is the occupancy going to vary with the time of day? You've then got to plot the population on some sort of grid, which is then going to allow you to do the failure frequency calculations and the hazard distance calculations associated with those. You've then got to construct the FN curve, and you've got to compare it with the criterion. So here you can see the site-specific FN curve plotted in red and the criterion line shown in black. So in that case, the site-specific FN curve has just started to infringe the criterion. What that means is it's essentially exceeded the criterion. So it's in the ALARP region, which means you've now got to do a full cost-benefit analysis of the risk reduction measures that could be applied. Right. I said that we were going to look briefly at some imaging techniques. The imaging technique which is probably most widely used at the moment is LiDAR, or light detection and ranging survey. Essentially what this does is uses a number of sources of information to create 3D images of the location. And it's used for a number of issues. The obvious one to show you is pipeline routing and route analysis, but the most recent application I've seen of this technique is very recent actually, and it's an operator using it to monitor changes in ground movement and changes in the pipeline location, because obviously you can't see the pipeline, but you can detect what it's doing if it's piggable, and the pigging tool has picked up any inertial data on the pipeline. So you can see that. So the technique is actually very heavy on data analysis. You've got to have good quality mapping data, you've got to have good quality aerial photographs, and you've got to have some sort of terrain model, which you get using the LiDAR equipment. Okay, so basically you bring all of these things together so that you can do a proper auto-rectification and georeferencing of all of the information. Once you've got that, you've got a 3D set of data which you can then use for a range of different purposes. 3D imagery is very important because well, the reasons are summarised there, but the main reason it's so important is it allows you to assess a complex situation very, very quickly, because people will look at the images and they'll immediately understand what's happening. Whereas if you get the information as a series of digital tables or whatever, it can take a long time to actually assess them. So a number of issues, but if we have a look at them now, you'll recognise some of these things when we start doing the assignment, because I've given you some of this information to use for the assignment. You start with the map, which has got a lot of accurate information on it, and then you superimpose with the map the aerial photographs. Aerial photographs give you a much better feel for what the land looks like and what's going on, but they don't have the level of detailed information that is available on a map. So you've got to merge the two. In order to get the essentially the 3D image of the ground, what you do is basically take a number of photographs and laser images of the ground. And essentially it's the laser pulses which are going to be constructed or used to construct the 3D image. This is really just saying, well, if you use standard photogrammetry used from photographs, or if you use radar and you compare that with what you get from LiDAR, the level of information is increasing all the time, which is why the technique is now becoming quite common in application. Right, so this is an example of how you create the image. So you've got the aerial photograph and you've got the mapping information. If you were doing a pipeline construction project, you would also need the geological information. And then this is the terrain data that you're collecting from the LiDAR survey. So you've got to merge all of those things. And then obviously the data is presented in some sort of visual form, which hopefully then helps you pick out the issues that you want to see. So this one is basically just color coding the relief of the area, so you can see where the high points and low points are. Obviously, depending, sometimes it might be helpful to have it in color. In other cases, it might be more helpful to have it in black and white, because our black-white grayscale can give you a more accurate assessment of any changes. And then you can use this to actually understand the profile of the area, and in particular the profile, the details of the profile where you're thinking of putting your pipeline. And you can do detailed analysis of certain sections. For example, this is showing the elevation model and terrain model associated with a road crossing, which you can then use to say, right, okay, I'm going to design the pipeline road crossing taking this information into account. Archaeology, obviously, because it's taking detailed information of the ground surface, there is the possibility that you can identify where you've got archaeology. Archaeology is the bane of pipeline operators' lives, because anything which is identified as having archaeological interest has got to be thoroughly investigated before you start constructing and obviously then destroying it. Flood analysis, as you know, flood analysis is becoming increasingly important. Because you've got a good 3D image of the surface, you can then easily do flood analysis where you're basically just putting a straight horizontal surface over it, so you can say, well, if it does flood, where's the water going to go? And then this is just in terms of visual impact. Again, this would be in particular in locations like the UK, where local populations get very can get very concerned and upset about developments going on in their vicinity. So this, once you've got the 3D image of the land, you can then say, well, if we put something there, what location around it would it be visible in? Okay, and then in terms of once you've created this image, you've then got a major data source that will allow you to bring in other sorts of information. So you've got the as-built details. You're then going to be collecting ongoing inline inspection data, and you're going to be relating, well, both of these back to a GIS system. And once you've got that, if you go in and you collect any detailed information about the pipeline integrity, then you can incorporate that in the system as well. So here is an example of where you've got that information and you're now superimposing the details of the pipeline from inline inspection. The inline inspection has identified somewhere where you need to go and investigate, so you can actually layer in the inspection, the assessment information, detailed photographs of what you've found, and then you can also include predictions as well. So there is the possibility of bringing all of this information into a very useful database. And then, of course, in terms of understanding inline inspection data, often it's useful to see the route of the pipeline over or on an image, for example a Google Earth image, and you can say, well, okay, we're picking up corrosion in this location, what's there that might be causing that corrosion. Right, I mentioned the systems which are in use now for doing aerial infringements. This is the photograph I showed you earlier of the drone image, where you're using georeference data and you're integrating that with vector data so that you can look at building proximity distances, land use plannings, inner zone infringements, and you can do a thorough ground-based analysis. This pipeline operators are moving more and more to this sort of assessment. And essentially, this is just another example of what I showed earlier on. You've got the pipeline route. This is actually a cleverer one because in this case they have actually mapped on the variation in the distances according to the design of the pipeline. And then obviously that needs to be related to map information so that you can pick up and identify as accurately as possible the developments associated with that. And then just to reiterate the use of virtual globes, obviously a lot of pipeline information will be immediately available to you in map form, but if you compare that with the information you get from a satellite image, a Google Earth image, you can see that you're going to get a lot more detailed information, and depending what that location's like, you may even be able to go in and look at a ground level view. Obviously you can't do that if it's very remote, but where you're looking, in particular if you're doing risk analysis and you're looking at pipelines in the vicinity of people, you can go down to ground level and do the assessments very quickly. So what you find, in particularly if you're involved with pipeline integrity consultancy, often what you will be asked to do is to assess quickly information that the operator's picked up, for example, from inline inspection, and what you really need to do is relate that very quickly to the ground and area around the damage, and use of systems like Google Earth allows you to do that very quickly, and to make quite intelligent assessments as to what's going on. This series of examples is just a simple series saying, well, you know, you can use things like this to monitor the right of way. Most operators would not rely on something like this. They would use much more detailed and accurate surveillance. But there could be locations where you're doing some work for an operator, and if you go back and you see a sequence of images, you can track the history of what's happened. There are errors in satellite imagery, and this is basically really associated with the process in which the different images are taken and then stitched together. So you do need to be aware of that if you want to use them. If you home in and look at some stuff in detail, you can often come across this sort of issue where the images are not directly aligned, and this is just to do with the fact that one image will have been taken by a satellite at a different location to another one. And then the other issue you've got to watch for is perspective projection, which I would have to say I don't fully understand, which can result in topographic displacement. And this is most evident when you're looking at something and you think, right, actually it just doesn't look right. So you can see that image looks okay. This image, it looks as if the cooling towers are actually bending in towards the centre of the photograph, which has got to be wrong, and that's just to do with the way the photograph has been distorted. Okay, so basically, in particular for people like you who are getting involved with this area now, the use of virtual globes is very important because it allows you immediate access to locations in the vicinity of pipelines. They provide a lot of information. You've just got to be careful how you assess it and use it. Right. Okay. So do you want to spend just a few minutes thinking about this tutorial question? See if you think that this is helpful. First 4 bullet points are important. When is a QRA required? You don't need to worry too much about the last 2 bullets. Okay?
Aerial surveillance. What is the duration when you talk about when an operator starts an aerial surveillance? Is it weeks or days?
The aerial surveillance on, you're talking about on a new pipeline?
Yes.
Normally you would start aerial surveillance immediately before the pipeline is commissioned, and the pipeline standards tell you to do it every 2 weeks. Yeah. Has anybody got any questions or any points you would like to make?
Can I ask a question, please?
Yes,
There was
sure.
a map, maybe 7 slides before, previously, where you showed the metal loss with red dots.
Yeah.
How you identified this metal loss? By
The me-
inspection?
The metal loss would have been identified by the inline inspection tool,
And
and
you
then
just draw
it's
it there, yeah?
then it's transposed onto the integrity management system, which includes the full GIS of the
Okay.
pipeline route. And if you include in that aerial photographs or virtual globe images, you can see exactly what's going on, and therefore is there something in the environment which is causing that.
Oh,
Yeah.
I went to a talk on high school and they were saying about how you could detect leaks from space. Or
Yeah.
How would that really work? Because surely there's those little bits of water happening there.
It's a very good point. You in some cases you can detect leaks from certainly from satellite images. If you think about oil leaks associated, if they're either under the sea or if they're in an area where the oil is going to cause pollution, you will certainly pick that up. Gas leaks are more difficult to pick up. Sometimes you will see vegetation discoloration. The issue is while it would pick it up, if you were using, for example, a satellite technique where you were dealing with pipelines which were very, very remote, that is quite important, because if you pick up anything associated with a leak, that justifies immediately you've got to go out and look. But those the systems don't give you enough information to actually control and assess the situation properly. They could tell you it's happening, but you're always going to have to go and look in more detail.
you showed this. So So you need CDC.
Yeah.
They're available.
Right, well, what I suggest we do now is take a break and then I'll start the operations and maintenance lecture. There's a couple of tutorial sessions in that as well, which really, the purpose of the tutorial questions is just to get you to think about the information in the way I want you to think about it, if that makes sense. Okay, so if we aim to start again about 10:15, is that all right?
But this is impression language, right? No problem. Yeah, I will not change. I will try. In your language.
I found that after your lecture slides, it was very different to what
The lecture slide, basically, it's none of the photographs are included. They are the latest ones, are they?
Yeah, I see the notes are, I checked the 2017 project.
Let me have a look.
Especially for presentation.
Right, okay.
And this tutorial caption actually.
This tutorial question isn't in the...
There's a separate file called tutorial questions, but it's not the same as what you showed us here.
Right, hang on, let me have a look. See what I've got.
And it's actually not doing
Everyone knows your address.
Because I came with the surveillance.
Right, so these are the notes.
But if we're all what is this? I have where we're starting.
How are you going to do the study?
So which slide are we looking
Will you do the notes that you got? I think there was a particular slide that you said was important, but you didn't have it inside here.
Oh no, Richard.
There was another slide.
There was another slide.
But we don't have that slide.
I thought there was a slide of a police concept. But we don't have it.
No, you don't. I haven't included the slides on how you do this because that's because I'm not going to interrogate you on how you do it. You need to know when you need to do it and why you need to do it. But I'm not going to challenge you on how you do it. Does that make sense?
More or less.
I mean, if you want any of the additional ones, I'll...
This is the first time I'm the last one.
I think these are okay.
Where are we having lunch then?
Yeah, that's the point.
So, which were the ones, you tell me which are the ones
Go ahead, we'll see what.
you're worried about missing out. Just, it takes ages to load, that's all.
Stupid dreams. Wait up to it. When you go to it, it's more. You're obsessed. We haven't decided yet.
I see. It's above 10 shots.
These ones.
Yes.
Right. Well, I put these in just to explain to you, and because it's an example of how you use Google Earth and things like that, so it is important. And it's what I'm really trying to do is help you link surveillance information to the QRA that you'll do. Have you done the QRA lecture yet, or is that?
We have introduction to QI.
You've had the introduction, right? So, but I think Graham Goodfellow does that.
Yes, I think that was his name.
Yeah, and I'm sure he does a second lecture.
Yes, there will be a second
where
one.
he'll go through things in much more detail. So it's, I'm really just trying to show you the link between surveillance type things.
And how you link it to QI.
But I'm not going to ask you about actually doing the.
Okay, that's good.
Is that all right?
Yeah, right?
That's why I want to take a break.
Matthew's a try. I'm sure my voice goes so much.
I sorry to bother you. I've just got a quick question. I was speaking to Gary, one of the external lecturers.
Oh yes, I work with Gary.
Yeah, and you mentioned that you've done some work with corrosion growth rates.
Yeah.
Is that right? Because that actually, for my dissertation, that's what I'm doing, in terms of from a deterministic and probabilistic point of view.
All right.
And yeah, so I was just wondering, like, in terms, because obviously it's not a linear, like the corrosion rate's not linear. I was wondering, what are the, other than like soil resistivity and temperature, what else like impacts like the corrosion rate?
The key issues obviously are the soil resistivity, temperature. They are the primary ones. But from most pipeline situations, the key issue are you protect the pipeline to start with. So you've got coating and you apply CP. So the coating is the primary protection. So the first issue is when that starts to break down, the CP will then start protecting, and the CP will affect the corrosion growth rate. Okay. So if the CP is working well, you should expect to have virtually no corrosion growth. However, the CP system will age with the pipeline, so as the ground beds get older, they don't quite give the level of protection. If the coating gets very damaged, the CP system will have to work harder, therefore its local issues won't be. That's probably the most difficult issue, modelling corrosion growth and linking it to the aging of the coating and the performance of the CP system.
Could I relate that to like in different environments of it, as like in an Arctic desert and...
You should be. I mean, there are publications around that. If you write to me and ask me, I'll send you some references that we've been using for that, which might be helpful. What we've been doing is modelling corrosion growth probabilistically, so that you can then say to the pipeline operator, well, if we make these assumptions about how good your corrosion protection is, this is what we think is happening in your pipeline, and therefore this is when you should expect it again.
See, this is exactly what I'm doing, to be fair, yeah, because but I think from probabilistic, I think we're doing box and match signaling.
All right.
I think, yeah. But like,
so I'm not good enough to know exactly how to do that, but I think I know what the technique you're talking about.
But I think that's the way we're going to go about it. It's still like in the air, like which way we're going to go about it. Because like that's what I was going to ask. Like, is there any particular way that you would like recommend?
In terms of actually using inspection data to determine?
Yeah.
No, to be honest, we would need to go to people who are much more knowledgeable about that. We would just use whatever the inspection company is telling us. So, who do you work for?
Oh no, I'll be doing this with Rosen.
Rosen have got some excellent techniques in terms of that. You know, they're one of the biggest inspection.
You can see it next to
But yeah, that's why I was just like asking for your opinion, because obviously Gary mentioned yesterday that you've had experience with it, and he did actually say that you might have some references, to be fair.
I can, if you can write to me and ask me, I'll send you whatever references I can. But yeah, we've done a lot of work for the UK gas industry, basically saying, right, you know, because what they've got so many pipelines, they've got to prioritise and screen the ones that they're going to inspect on an annual basis. Well, they don't. The UK gas industry, and they use either Rosen or PII for their inspections. A lot of them are Rosen inspections.
Yeah, that's how I got in touch with Rosen, because I was collaborating with National Grid last year with for my first dissertation, and that was in Barn as well. But we've moved on to corrosion rates this time around. But like obviously, I've not really had much experience in it. So, but like Gary mentioned yesterday, temperature and soil resistant is the main topic.
Yeah. Right, okay, well I can definitely send you some references which will start you off on that. But I always, certainly people who are studying at this level say, if you're interested in corrosion and you get into it, you'll have a career for life, because you know, pipelines are they're long life systems. A lot of them are aging, and corrosion is the biggest issue to manage.
Perfect. Okay, I appreciate it. Yeah, I'll definitely get in touch with you then. Right. Okay, thank you very much for that. Appreciate it.
What is she doing? This is oh, you're taking out for no. I was going to say, why did you pick to that? It's quite positive.
My culture is really so I want to introduce you to your American culture, because you both speak English. So you like cheeseburgers and pancakes and all that stuff.
No, but I'm just saying, like, you're still your culture technically. You wouldn't
So you rate Americans. Well, but in this case, the sun overtaken by our PI is Brazil, the one in Spain.
Obviously, it's something that you know as well. Like if it's all your family, it's Spanish. It's really cheap actually. I feel bad. For two, I don't know if I've read it right, but from what I've read, right, it's like a tablet straight out of the back, but like you get 6 or 3 each, like £15, 3 each. So it's like 750. And this is like, this is more like a chocolate rather than just. You get a bottle for about 90 and that's the top rate. You don't necessarily buy me £5, you're not
but you have to
it's convenient. All you need to do is get a couple of drinks till maximum. Just so they go there. I'll get the
it's not, but she's going to make me pay for everything. But she's the kind of woman that likes someone else to be able to do it. Well, it depends on that. I mean, I was planning to come to regardless. But it's bigger. Who is this guy with bigger? So that's why I need to come to GMT.
I need to start properly.
I was going to ask if you want to try like a routine like this.
Yeah, we go for it, mate. I need to get
You know what a super is? Yes, when you combine, let's say, two exercises, after you finish what you move to that's one. Yeah, it should be good because there's something called drop set. And the drop set is that you make the push-ups or whatever, and then when you fail, you can reach it, and when you can lift it anymore, you lower the weight. You continue until you fail again. So it needs to be like in pairs. When one is working, the other one is assisting. No, because the weights are going to be different and not going to be lifting your weight.
Yeah, true. The only problem is you'll finish before me in 10 minutes. Fast time, so no, fast time. Then I got that.
No, but I want to dive like 2 kilos. Yeah, because we're gonna do only like 3, maybe 4 drums. Yeah, you're not gonna lower like kilogram per kilogram. 20, like 10 sets. I was doing that yesterday with the shoulders. And you see the last one, every little thing. Do we have that machine that is for triceps? We did that one. The one that is for
Not 3 or 4. Yeah. Yeah, we'll do that. But I can't sit down.
He's making the move. Actually, he licked it. Are one of my friends, my girlfriends. And he said, do you know Sean Paul? Yes, I do. Why do you ask that? Here in my LinkedIn. Car just went to all my contacts and add someone randomly. My friend wants to talk in English with her. She wants to practice. Well, what is true, like if she is not pronouncing well her English, I won't be able to. So she needs to make sure that she's speaking properly. Because if I say like I,
but then also the reverse, like V's not pronouncing something properly, she's going to learn. So which way would you
it's a win-win. But if I tell I come yesterday to gym. Because you don't understand. You don't understand. You don't do it. Come on, you need to do it, man. And you're gonna be correcting me every second. I don't know why when I'm feeling so hard. Because when you're right, that's what I don't do. Come for a assignment. I'm drinking. No.
Oh, yes, yes. Yeah, it was great.
Don't wait. For the B actually. Is it and for B? Whose cat is that? Why he left it there? Could have gone cheese as well. I left it there. So you need that before you go to...
Yeah, of course.
After Easter.
We need to check. I think
Where are you going to? Singapore. I'm going to Singapore. Where are you going? Croatia. I'm going down to London. I'm going to Croatia for 1 week. Where? Croatia? Croatia. Why Croatia?
Yeah, which is really
Go for right, not soft enough. Wow. With your friends.
right. Is everybody okay to start again?
Yeah.
Right, well, I think the reason I do this lecture is because it's seen as required, but it's incredibly boring. And so nobody else wanted to do it. So you'll just have to bear with me. Maintenance and operations is generally quite boring, but it's absolutely essential in terms of keeping the assets going. So I'm just going to go through some overview stuff. First of all, those of you who are interested in or who've ever done any work on maintenance strategies will know that there are a number of strategies that you can apply. Some of them are very applicable depending on what sort of systems you've got. Others, you could say, well, is there really anything different between a time-based strategy or a duty-based strategy? Some case, it does depend on what sort of asset systems we're dealing with and what the operational requirements of those systems are. So we'll touch on how maintenance philosophies might apply to that. I'm going to look at operations and maintenance. They're often, people often talk about operations and maintenance. They are actually different activities, so we'll try and draw that out. And I'm going to cover installations and pipelines, installations associated with pipelines. Right, now the systems in terms of pipelines are generally, are you talking about a simple pipeline, a complex pipeline, a pipeline system, or a pipeline network? And basically these are the two complicated ones. Pipeline system is generally seen mainly associated with liquid pipelines, where you've got to link key facilities, like reception terminals to storage bases, etc. And you've got a number of different things you've got to manage to keep those facilities as efficient as you can. Pipeline networks are probably mainly associated with gas supply systems anywhere in the world. because in most cases, once you've started supplying gas, in particular when you've started supplying gas to domestic properties, you've got to keep supplying it, and you can't just easily close down parts of the network and then expect that whatever's connected to the end of the system is going to remain safe. So there are different issues. Often you find with liquid pipeline systems, once, for example, if the operator finds that they've got damage or they've got a problem, they will just stop the system, decommission it and sort it out immediately. With pipeline networks supplying gas, the operator may not be able to do that. They may not be able to immediately isolate the system because there will be demand requirements. You don't just suddenly want to cut people's supply of gas off. So you've got to balance these different things. You also have to take into account the characteristics that you're dealing with. So for pipelines, they're often located in remote locations. They're buried. They're on third-party land, and they generally are unmanned and subject to remote operation. So you've got to take all those things into account when you're thinking about the operations, what information you want, and the maintenance, what interventions are you going to carry out. Installations are, the installations associated with pipelines are generally simple processing plants. Anything complex will probably not be on the pipeline. It will either feed into the pipeline or it will take whatever the pipeline is delivering. Usually above ground. They're normally in a secure and controlled compound, and they will have a major influence on the pipeline availability. Operational requirements, you've got to consider the mode of operation of the pipeline. Is it continuous flow, or so continuous flow typically would be, some liquid systems which are supplying critical fluids will be continuous flow. For example, in the UK, that could be pipelines which are supplying airports with fuel. You might have batch and cyclic flow. So you'd be aware that, for example, in some liquid pipelines will be used to transport more than one type of fluid, and in that case what they'll do is they'll send them, they'll transport them in batches. So one day it might be transporting aviation fuel, the next day it might be transporting gasoline, whatever. And that will introduce cyclic duty in the pipeline. You may have non-critical availability. In other words, if the pipeline goes down for a few days, it's not going to cause any major issues. Or you might be dealing with a critical system, for example, a major part of the gas supply system. Then the other issues you've got to think about, more associated with installations, are the assets standalone, or have you got any sort of redundancy available? And what about safety devices? Safety devices associated with pipelines are very important, because if the safety device is set wrong or if it doesn't work, you've got the potential to overpressurize a pipeline, which then might be routed very close to population at some point. Right, so by operations, what we're really talking about is how the pipeline is being used, what controls are placed on it, and what information does the operator need to make sure that the operations are being undertaken as they expect. And in particular, that would involve measurement and control of pressure and flow rate. Also, the issue is the status of the pipeline and installation. So we've said that pipelines are remotely operated, so the control room will not be will be remote from the pipeline. It's reasonable to assume that, and therefore what information is available in the control room to let the operator know what the status of the plant is. So for example, have they got full monitoring of all the equipment on installations? Do you know what the position of all the valves are? This sort of thing. The operations is involved with system checks and testing, basically because everything's remote, going through sequences of activities just to check that it is actually working and it is sending you relevant information. And obviously operations are in charge of safe control of all activities associated with the assets, in particular isolations, decommissioning and recommissioning of plant. So the majority of operations activities centre on monitoring and control through the SCADA system on the pipeline. And they are key to the coordination of activities on the plant. So in terms of setting control limits, one of the responsibilities in the operations centre will be to keep detailed records of, in particular, the pressure. Remember, the pressure of the pipeline, particularly high pressure pipelines, it's a statutory responsibility to notify that and to demonstrate that you're keeping it under control. So there are a number of issues that will be recorded here. Obviously, the maximum incidental pressure of the pipeline will be noted. That is normally what you would take as the safe operating limit of the pipeline. So you've got the maximum incidental pressure and you've got the operating pressure, and you've got to obviously you've got to have a margin between these two things because you've got to try and control it. So basically, anything that exceeds your normal peak operating pressure normally would be notified to the regulator, and if you exceed the maximum incidental pressure, you are operating. Essentially, your operation's illegal, so you're likely to get some sort of prohibition notice. So one of the key things here is establishing what's your peak operating pressure in relation to your operating pressure. This will be associated with the characteristics of the control system, because control systems will never control to a dead limit. There will always be a variation above and below. So you've got to establish what that is, decide whether it's reasonable, and then keep the records to make sure that you're to demonstrate you're in control of that. And basically, what you're really doing is taking signals from remote plants such as this, which are this is a picture of volumetric regulators on a large gas system. The other issue, in particular for gas systems, is temperature control. Obviously, if you are operating installations which are going to reduce pressure and feed into other systems, when you reduce pressure, you're going to significantly drop the temperature of the gas, which obviously will lead to situations where you could damage the equipment itself if you allow very low temperatures to occur over long periods of time. Right, the maintenance of installation. The maintenance, there's lots of different strategies that you can consider here, but the maintenance strategy really needs to be devised based on the likelihood and consequences of failure, including when you see likelihood and consequences of failure, your immediate thought would be safety consequences, which of course are true, but you've also got to consider failing to supply, and also you've got to consider the business risks as well. If you so you've got 3 levels of risk to consider: safety, security of supply, and economic. In the absence, normally the current best practice is to move to some sort of risk-based approach, okay? However, to move to a risk-based approach, you've got to have data. So in most cases, if you haven't got data you can rely on, you would fall back on equipment manufacturers' recommendations. A couple of just tedious definitions here. Essentially, you're carrying out maintenance to make sure the physical assets carry out their intended functions as required, and it's important to recognise it's a combination of management, technical and administrative actions which need to be carried out. Okay, the administrative actions are probably the most difficult and the most important. This is to do with actually scheduling activities, recording that the activities have been allocated and then they've been carried out, and what's the outcome of those. And obviously if you're dealing with extensive assets, that can be quite onerous. Right, in terms of strategies, this is a typical list of maintenance strategies. And what you would find, certainly for any pipeline system, you probably find that you wouldn't actually use any one of those individually. You'd probably use a mixture of those. And the strategy you apply to some extent depends on what resources you've got available. So, for example, if you need to retain emergency standby teams on your pipeline assets, then you don't really want an emergency team sitting in a control room playing cards and doing nothing, so you may as well come up with useful activities that they can go and do on the plant, which keeps them familiar with the plant, how it operates, etc. However, if you don't have a requirement for an emergency standby team, then you would perhaps want to minimise the activities that you carry out. Also, if we now think about the data that you're going to need, that will depend on what monitoring you've got, what fault data you're recording, have you got any failure finding procedures in place, and have you got a good data capture and database recording system. Right, there's a couple of slides here which are in the notes, which basically give you the summary of advantages and disadvantages of the different types of maintenance. Breakdown maintenance, people would say, well, you really wouldn't really choose to go to breakdown maintenance, but for some assets you probably would, because for example, if you think about valves, there's not a lot really you can do to a valve. If it doesn't work, you've got a problem, and therefore what we've got to do is say, well, you know, we'll use breakdown maintenance for most of the valves on the system, which means you've got to hold spares, etc., and you've got to need to know what to do if you do have a breakdown. This regular time-based strategy is probably the easiest to apply. It certainly makes planning and management of resources easier. However, the problem can be optimizing the interval. It's very easy to set scheduled maintenance at frequent intervals, and then to find that you're spending all your time chasing administrative tasks and you're not actually doing anything useful. So that needs to be thought of. The next stage there would be to say, well, really you need to bring in condition as well as time. The issue with condition is you've got to be able to monitor changes in parameters, and those changes, you've got to be able to pick up changes in the parameters and be able to use it reliably. Scheduled overhaul. Again, this is very easy to manage, and generally scheduled overhauls will be applied to redundant and safety critical plant. They are high cost, and therefore if you can move to something like a reliability centred maintenance or risk-based maintenance, where you're homing in on identifying the components which really do need to be maintained, because if they fail, you're going to have a major problem. So these offer you a lot of advantages. They are also high cost, mainly because eventually they will home in on the need to carry out onerous and expensive activities. So moving to RCM or risk-based doesn't necessarily reduce your cost base, but it does allow you, once you're collecting the data, it does allow you to be in much more control of what's going on. Right, risk-based maintenance, as I said earlier, risk-based maintenance is probably what is recognised as good practice now, and most of the pipeline standards that actually cover operations and maintenance will encourage people to go down this route. However, you need to bear in mind that if you're going to apply it, you've got to have a good inventory of your equipment. You've got to keep a comprehensive history of all occurrences, of any defects or failures, and the work undertaken to correct them. And you've got to be able to rely on that data to define activities and frequencies. The number of factors that need to be considered, the age and standard of construction. In the safety lecture we mentioned the fact that as pipeline standards change, you've got to consider the fact that you may be operating something which is 40 or 50 years old and doesn't meet the requirements of current standards in terms of design and construction. So how do you deal with that? You've got to deal with it somehow in the operations and maintenance strategy that you apply. You will be collecting a lot of information through inspection and maintenance, and the monitoring, certainly for pipelines, the results of CP monitoring are very important. Local ground conditions and the environment, infrastructure, population density, all of these will direct you towards particular high-risk situations. Operating pressure and temperature history, safety consequences. In other words, the key thing there would be the hazard range associated with any failure that may occur, and the operational consequences in terms of loss of availability. So, risk-based maintenance requires some sort of inventory model. As you do risk analysis, you'll see a number of inventory models, and the key thing there is really defining quite accurately what could happen and then associating probabilities with that outcome. You've got to make some attempt at predicting the frequencies of failures, and you've got to be able to do some hazard analysis, which then feeds into the modelling and prediction of consequences. And then finally you've got to do the risk analysis, where the risk is equal to some function of the probability of failure times the consequences of failure. Now, when you're doing risk-based maintenance, while on this course you will be looking at quantified risk assessment, which is absolutely essential and very important for pipelines, particularly for safety aspects. When you're doing risk-based maintenance strategies, you often will not have adequate, what you would really call adequate quantified failure probability models, and you may also not have proper consequence models. So you will be moving from a fully quantified approach to either a semi-quantified or a qualitative approach. And as you make those steps, you've got to take on board where you may be losing serious accuracy in what you're doing.
So risk-based maintenance, are we doing it segment by segment?
You should do, yes. If the risk-based maintenance is going to be of real value, yes, you've got to segment, and you should be segmenting based on likelihood of failure and consequences of failure.
As an example, we have a series of compressor stations on a gas pipeline. If the first and the third needs maintenance and the middle one, the operator thinks that there is no requirement, so will they skip it or they do it for the...
That is essentially how you would apply this. You know, you would look at the risk and say, well, if the first compressor station goes down, you're not going to be able to manage the pressure in the pipeline at all. So it's essentially do that one. The downstream booster station, if that goes off, might not get totally efficient performance, but you're not going to stop the pipeline operating. If the next booster station goes down, then you're not going to get the full capacity of the pipeline. So yes, that's exactly the sort of thinking that an operator would apply.
Sorry, question. Regarding this RCM and RBM, what is the difference between them?
Between risk-based and reliability, well, risk-based, you're looking at the simple function of what is the risk of failure and what are the consequences of failure. Reliability-centered maintenance is a much more detailed assessment where you're actually looking at the reliability of every component within the system. So risk is looking at failure.
Okay, only risk-based, yeah, where you have, for example, certain risks and others, so you will do the on that unit.
Yes.
Your maintenance strategy, you will focus on that, yeah?
Yeah.
But on the reliability, you will do all the plant, yeah?
That's a good point, and that will depend on your resource strategy. If you use risk-based approach and it highlights, for example, an installation or something that you need to do, then the ideal situation is you just go in and do everything. However, if you are constrained by resources or time scale, you might say, what is the key risk, what is the key aspect of that is controlling the risk, and you may just go in and deal with that.
Okay, so difference is RBM you will do in case of high risks, and you will go and focus on the risks, yes?
Yeah.
For the RCM,
the RCM is to do with reliability. So the main focus of RCM is making sure that the equipment is available. Okay, you're looking to maximize the availability and reliability.
yeah, it's like proactive maintenance. No?
Preventative.
Yeah, I mean, proactive or preventive.
Yeah, RCM would generally you would be using RCM to maintain before you had a failure. So you'd be looking at mean time between failure and downtime, etc. And you would do the analysis to make sure that you constructed your maintenance program to target in on the components that are going to control that.
Yeah, okay, this is RCM. RBM, it's more like preventing maintenance. Or
yes, that's really. I mean, you could argue that a very simple way of looking at it would be RCM. You're basically saying, right, well, we're not really going to concentrate on avoiding major failures because we want this to be highly reliable. If you want something to be highly reliable, you'll maintain it, and in doing that, you will automatically avoid major failures. So, typical example of RCM would be aircraft. You know, where you certainly, if anything major happens to an aircraft, you've got massive safety issues, but you're operating aircraft for them to be highly efficient in moving people around. So you want them to be as available as possible, and in doing that, you end up avoiding the failure. Whereas for risk-based maintenance, what you're saying is, for a pipeline system, you could be saying, the pipeline system, the risk of failure is actually quite low, and therefore we're going to push out beyond full reliability, and we're going to move towards managing the risk. Is that okay? Right. And so this is really just a typical or a simple explanation of this. The reason I've included this slide is because standards all tell you to go to a risk-based approach, and the immediate thought, particularly from management, is if risk-based means you can move from detailed time-based scheduling, we're going to save money, so do it. But you really need to be able to demonstrate you've applied this process. So you've got to think about what could go wrong, what are the consequences of it going wrong, and how often will it go wrong. So a typical example here, there's a lot of interest in the pipeline industry at the moment in using, moving to risk-based scheduling of inline inspection. Okay, and therefore what can go wrong is you could get metal loss, which could lead to failure. The consequences of it going wrong would be a leak or a rupture, and you've got to think about those consequences along the length of the pipeline. And then how often will it go wrong? That depends on modelling of corrosion rate. So you've got to think about applying that approach to every specific activity and damage mechanism that you're considering. Okay, so just taking this one step further, you've got to have some form of risk model. So with what we've just been talking about, you would need a corrosion growth model. And if you were applying this to surveillance, you would need to think about if you reduced your surveillance interval, what would that do to the likelihood of you missing any third-party activity in the vicinity of your pipeline that could cause damage, which, so straight away, in this situation, you're going to have a corrosion growth model, and in this situation, you're going to have a model which is giving some sort of prediction of the activity levels around your pipeline. And you've got to be able to demonstrate that if you adopt the risk-based approach, the frequency will not result in an increase in risk. So you can see that although there are a lot of strong advantages of taking this approach, it's actually not necessarily straightforward or easy to do it. You've got to think about it properly. And the last point there is damage and failure data is key to being able to do it properly. Right, well, I won't go through this in too much detail, because essentially this is really just common sense. But you basically, these are the main activities that you're, or the main strategies that you're talking about, and risk-based maintenance is essentially a mixture of all of those things that you've selected based on the risk assessment that you've done. And then it depends where you're going to apply them. And it's important to remember in some cases that where you're dealing with safety devices and pressure vessels, there will be statutory requirements that you've got to meet there. So the statutory requirements will mean that you've got to do tests and checks at certain intervals, and certainly on pressure vessels you have to have authoritative inspections carried out at regular intervals during the life of the vessel. Right, so we've got a summary of activities. Maintenance involves really doing all of these activities, right? And scheduling them at a reasonable frequency so that you can actually control the outcome. So if we look at these, what this is basically doing is saying, well, how could you apply different strategies to these different requirements? And the point that was made earlier, I think when you were making, is if you've identified something you're going to do you just do the whole plant, or do you just home in on the component on the plant? Well, this is just a photograph of a typical fairly old gas installation, and you can see that there's different sorts of equipment which will have different levels of criticality. We've got water bath heaters in the background, we've got the pressure control equipment here, there are filters and things, and you could say, well, actually if you go in and you do everything that's required on that site, that could be quite enormous workload, but equally if the site's remote and you've got to get people and equipment to the site to do the maintenance, why not just do everything at once? So there's a balance that needs to be considered here. Right. Now, these two slides that I'm going to show you now are quite important. They're in the notes, all right? What we're looking at here is what sort of activities do we carry out and what frequencies do we carry them out at. So, routine checks, basically that is a standard, normally to sites. It would be, the sites are all unmanned and remotely operable, so you've got to visit them every now and again just to check, is everything still there and is it still operating, is it still set to operate at the right level. Then you've actually got to, so that is basically just a routine security check, is everything okay? Then you've got to think about functional checks. And that's to do with making sure that everything's working, and in particular the safety devices are okay. And it applies to virtually all of the equipment that you've got on the site. And the frequency varies typically between, say, once every 4 months, perhaps going up to every 12 months. If you can push it beyond 12 months, then you would, but that would depend on the components and how they're behaving. Then you've got the major overhaul, which applies to all the key mechanical equipment. So typically on a pipeline installation, pressure control equipment, the small bore controllers, which are probably going to be one of the biggest headaches, heaters, valves, filters and meters, and generally you would schedule that in accordance with the manufacturer's recommendations, mainly because if you don't and something goes wrong, the manufacturer isn't really going to be very supportive if you're looking for any kind of help or compensation. Equally, if you've got good operational data which allows you to make the decision to change the frequency, then you would. Okay, now on this particular slide, this is really just continuing that theme. But one of the most important things that you've got to think about with high pressure equipment would be pressure system condition examinations. In most legislative regimes, the operator will have legislative requirements to demonstrate that the condition of the plant they're operating is acceptable. And what this means is you've got to go through a series of standard visuals and inspection checks, and what you're looking for is damage and deterioration which could lead to a loss of containment incident. Okay, and this is quite important because it applies to all components and pipework on the system. And a typical frequency which would be used in the UK for this would be typically every 6 years. In some cases it might be every 10 years or it might be every 12 years, but that's a typical issue. And then finally you've got replacement. The issue with replacement really is tracking and understanding the obsolescence of equipment. And the problem you've got is because pipelines are long life assets, there are a number of things which could become obsolete during the course of that lifetime, but the overall the main assets will not become obsolete. The pipeline won't become obsolete. The pipework at the installation won't become obsolete, but the controllers that you're using and linking in with your SCADA system may well become obsolete. So you've got to watch things like that.
In one compressor station, there's a custom installed gas turbine for a gas pipeline.
Yeah.
And since it is custom made, like for example, supplied by GE vendor, and they find a fault in the compressor during the time of maintenance, and when they contact the vendor, they are engaged in another maintenance contract with some company. So in such cases, how do we respond for the maintenance?
That's a good point, because if you're talking about something like a gas turbine, that's a major piece of kit, and it's a contractual issue basically, because you will need access to the equipment suppliers' experts to do the maintenance, and therefore the contractual setup that you've established with them needs to make sure that they will respond within what is a reasonable time. Something like a gas turbine could develop a fault in it. It may need immediate, well, you're either going to have to decommission it or you're going to have to deal with it straight away. So, yeah, there's a lot of, it's a good point actually, there's a lot of underlying contractual issues here, which I haven't touched on at all, but would certainly influence the any risk-based maintenance that you applied.
Sorry, question. You mentioned the importance of this table here. Just I'm wondering, for example, in the exam, how you expecting to answer this kind of questions?
Well, I've got a tutorial question, but the bottom line is you need to know.
Yeah, because like for this table, yeah, you can answer do inspection, do this, you have you should list a certain answers. Yes?
Yeah.
But you don't need to, I think, you don't need to write essays again. For example, answering with
Well, on the basis I'm going to be marking it, no, please don't write essays on maintenance.
yeah, because you should, some of the guys, they're asking for the essays thing. But for this kind of question, I don't think that you need to just list the answer, that's all, yeah?
Yeah, you need
that's
what this, well, you'll see I will be looking at a tutorial question that we can talk about in a minute. But the bottom line is you've got to give, you've got to be able to give an accurate, factual answer. And if you can do that in a minimum number of words, then good for you. It's got to be good. Okay, but we'll think, yeah, I'm not looking for this particular subject as I'm covering it. I'm not looking for major essays on maintenance strategies or anything of that type. Okay.
Regarding your explanation about the previous page about the pressure system condition utilization.
How long was it?
Previous the tables.
Oh, sorry, I'm going the wrong way. Right, these ones.
The next page. So when we are talking about the pressure system, does this mean including like the pressure vessel or something like that?
Yes.
Like internal inspection?
No, well, internal inspection if necessary. This applies to all pressurized components in pipework. Okay. Now, in some cases, with critical pressure vessels, to do a proper inspection, you're going to have to get inside them. So you're going to have to decommission them, and you've got to actually get in and do proper inspection. With pipework, it might not be practical to get inside. You may not have techniques that you can do internal inspection on pipework systems. You could argue that for most pipework systems, any critical inspection you need to do, you can do externally anyway. You may need to dig parts of them up or whatever, but you can do it externally. But the key requirement here is to look for damage or deterioration which can lead to a loss of containment. So you're really talking about key damage mechanisms there. The main one with metal components is going to be corrosion, metal loss due to corrosion. For pressure vessels, you may also be considered, be worried about fatigue. So you're going to have to go and look, you're going to have to say, well, where, if you have got fatigue damage, where is that going to occur, and what techniques do you need to apply to look for fatigue cracks? In other cases, you know, if you happen to have perhaps a badly designed installation where you've got very high internal velocities, you might have erosion. You could easily say, well, if you have got erosion, that's going to occur. Changes in direction in the pipework, so you've got to inspect. So essentially what you need to do here is you've got to do all of these things, but you also need a very good procedure as to how you're going to do them and where you're going to look.
And the frequency required by regulation is 6 years.
Typically in the UK, something like this would be around 6 years. In some cases, for some components, the operator may say, I'm going to move that to 10 years or 12 years. Or in some cases, they may say, I'm only going to do it when I'm going to use the piece of equipment. So for example, that piece of equipment might be a pig trap. You're only going to use a pig trap when you're going to inspect the pipeline. And so if you're inspecting every 5 years, you need to make sure it's okay. But equally, if you're only inspecting every 15 or 20 years, you might say, well, what's the point in looking at it every 5 years if I'm only going to use it once every 15 years? So you've got to link the two. Okay. Right, so I've got, there's a checklist of what you would look for in terms of routine checks. The routine checks are the ones that you would do most frequently, and really what you're doing is just checking that everything's okay. So typically, are your fences and gates okay? These installations are supposed to be secure, so if they're not, that would be a problem for the operator. Have you got any environmental issues on site, for example, flooding? Is everything stored correctly? Are the relief valve vents working okay? And how are the inlet pressure, etc.? Are all the settings okay? And you know, this could actually be as simple as the control room's got one set of readings, and are they actually what's visible on the component? Okay, so a simple checklist is really what's needed for a routine check. Then functional checks. This is essentially a more detailed list, and also checks. So rather than just looking at the regulator and seeing is it set properly and does it look as if it's working okay, you've actually got to check that it's working. So you've got to look at the open-close action, check for leakage, look at the small bore pipework, which, as I've said, would tend to be where your problems would be. Look at all the set points, in particular check relief valve set points, and very importantly, check the slam shut valves and make sure that they're okay. And that will include checking the actuator performance. Then, depending on what other equipment you've got, heaters, for example, heaters can end up being very costly to maintain, so it's always good to have a good functional check routine to anticipate any problems that could be building there. And then, you know, certainly your pressure control equipment will actually consist of a number of different components. So does the assembly itself, is that working properly? Right, okay. So here's a tutorial question to consider. So a pipeline inlet pressure reduction station includes regulators, valves, including the ESD, filters, preheaters, and a pig launch facility. The outlet pressure reduction station includes regulators, valves, and a pig receipt facility. So the inlets and the outlets are not terribly different, they're just operating at different levels. Right, describe the maintenance requirements for this installation. So based on what we've covered, do you think you could do that? And so you describe the maintenance requirements for this installation. The maintenance requirements are going to be routine, functional, inspection, a pressure systems type inspection, and major overhauls.
Can you apply for this, like for the filters, preheaters, like different
Yeah.
strategy?
Well, you need to think about it. Yeah, I mean, would you do the same for a heater as you would do for a regulator?
Yeah, we will apply, I mean, different strategy for each system, like heating system, heaters, and different strategy.
Well, for all of the components, you're going to have to do routine, functional inspection and major overhaul activities, and the frequencies that you're going to apply are going to vary according to the type of equipment. The key differences in features are in the table. Frequencies are in the table. The tables that I've given you, which are in the notes.
So we
Okay.
don't need to mention about strategy, but like you listed strategy, no?
No, for the way that question is worded, I'm not asking you for strategy. I'm just basically saying, what do you need to do, and typically, when would you do it? Okay, so I'm not in that sort of thing. I'm really expecting you to say, well, the activities you need to do are these ones, and typically you would do them at these frequencies. I'm not expecting you to write a detailed justification of for this particular component it would be worth looking at an RCM strategy, because what you would do there is, I'm not looking for that level of detail.
In terms of the examination, like each person, like each external person who's come in, like do they set a question each? Like how is the format?
Well, it's sort of evolved over time. I am normally asked to set 3 questions.
Okay.
Other lecturers might only be asked to set 1.
But how many like questions is the overall, and how many do we need to answer?
All right, that's a good point. I can't remember. I think the exam paper has got 6 questions on it, and you've got to do 4. So if there's if there's a subject that you absolutely hate, you can say, right, well, I'm just not going to bother with that one, and take a risk that something else is going to be on the paper that you can answer, which is always the case with exams anyway, isn't it?
If you accept short answers, I will go with this answer.
The only thing is, the discussion we had earlier about we're looking for factual information. Just make sure you get it right.
Yeah.
You know, you could write for something like that. You could write maybe 3 or 4 lines as your answer, and you could get full marks. You could write a page and a half and get virtually nothing because you missed the point. So I think one of the key things I would ask you is, please read the exam questions. I had a perfect example last year where I had about half the class answered a question that I had set, and most of what they'd said was correct. They answered the wrong question. That wasn't what I was asking them, but So please don't just look at the question and think, oh, that means this, and then regurgitate a load of notes. Think about what's been asked and make sure that you answer that as accurately as you can. Okay, so basically what this is saying is, what are the maintenance requirements for this installation? The maintenance requirements are, at a basic level, what I've put in those tables. Okay? And then provide a recommended list of activities and recommended frequencies. And I've said including how these are derived. Sometimes I ask people to say, right, well, if you're going to change your inspection frequency, how would you actually go about estimating that? Okay. I haven't found that sort of question to be terribly successful, so I'm not doing it this year. Right. And then what are the key issues for the operator to consider? We've looked at that. There's a slide on that. What are the key issues? And that's to do with I can't find it. I better check it's in the notes. The key issues are where is the installation, has it got full telemetry, all very basic stuff. But you know, if you've got an installation which is out in the wilds, it's got very minimal telemetry, then you make damn sure you look after it, because if it goes wrong, it'll probably be a while before you find out it's gone wrong. There's factors affecting maintenance frequencies. There it is. Right. So what that's saying is, right, what are the site characteristics? Have you got minimum telemetry? Can you provide immediate response to any alarms? Is the installation critical to the performance of the system? Have you got any sensitivity to any environmental factors? In other words, as soon as the wind gets above a certain speed, are all the aerials going to come down? If you've got low temperature, are you going to start getting freezing up of the control equipment? Is it in a location where you could have flooding, and if it does flood, what's it going to do? Is it going to fail safe, or is it going to give you a problem? And is it secured? This is becoming more important now, mainly with threat of terrorist activities. Certainly in the UK, the Health and Safety Executive are homing in on operator installations and saying, right, how would you deal with a terrorist attack? And then telemetry. The issue with telemetry is, what telemetry have you got? In most cases, if the site is well designed, because the sites, all the sites are unmanned and remotely operable, in the event that you lose all the telemetry, the site should continue to operate. The issue is, if you lose all the telemetry, you won't know what it's doing, but it should be still operating. And therefore, the level of telemetry you've got may affect. If you've got full telemetry and you've got good telemetry records, you may say, actually, we're going to skip the routine check next month because everything seems to be okay. Right. Is everybody okay with that? Right, so let's move on now to pipeline operations and maintenance. This is really just looking particularly at the pipeline on the basis that it's a linear asset which is laid on third-party land generally, and the risks you've got to manage are essentially the key integrity of the pipeline is set by the design, the construction quality, and the testing that was done at commissioning. And then, so that gives you a base level of integrity, okay? And then you've got to think of, well, what could happen on an ongoing basis that could reduce that integrity? And then that's where you start looking at the typical damage mechanisms that could affect fatigue, corrosion, third-party damage, mechanical failure, or ground movement. Okay, and the activities that you actually apply to control all of those things is the operational activities that we talked about, which are all to do with setting limits and monitoring how the system's performing, making sure that it is operating within its pressure boundaries and temperature boundaries. Surveillance, as we talked about earlier this morning. Surveillance is probably one of the most important activities that you carry out on a pipeline, simply because pipelines are generally expensive, and they do carry large amounts of inventory, and you've got them in locations where third parties can cause damage and disruption. Inspection, maintenance and non-routine activities.
In the case of surveillance for a cross-country pipeline, the helicopters have the boundaries like countries. So, is it stopped or?
Right. So you're talking about where pipelines cross country boundaries. That's an operator issue. The operator cannot not survey just because the pipeline is going through another country. This is to do with the contractual agreements which are set up at the beginning. So if you're setting up if you're building a cross-country pipeline which is crossing borders, then it's essential before you start operating it that you've got all the agreements in place to allow you to carry out all of the activities that are needed. Okay. Right. Now this is actually, I think this is quite a good table. I've pinched it from ASME B313.1.S. And what this is doing really is looking at all of the different activities that you would carry out on a pipeline, and then it's basically indicating which of the failure mechanisms that you're controlling by those activities. And one of the things that the ASME code is doing in getting you to think about this, well, if you've got any damage mechanism there in your list which hasn't got any crosses in it, then it means you're not managing it. Right, so third-party damage, we've covered this really already in the surveillance lecture, and also what we've talked about in terms of safety. You manage third-party damage by, first of all, routing the pipeline carefully, in particular so that you're avoiding areas of activity and population. You've got to mark the pipelines with marker posts so people know where they are. You use thicker wall pipe in built up areas. You're controlling the design factor and you're making sure the pipe is resistant to damage. You provide additional protection such as concrete slabbing over the pipeline where you've got vulnerable areas. In the event that work needs to be carried out in the vicinity of the pipeline, you should go out, mark the pipeline route, and this doesn't just mean with pipeline markers, it means if somebody's going to be digging up a field and your pipeline goes through the field, you actually mark where the pipeline is across that field. And in reality, you should be there to supervise the work. Liaison with landowners and other key stakeholder groups. Other key stakeholder groups typically would be contractors who do work in the area. You've got to manage a third-party inquiry process. In other words, if somebody is going to do work in the vicinity of the pipeline, they should know the pipeline's there, and they should be able to contact the operator and ask for any additional information if they need it. And then finally, the surveillance, or either aerial or vantage point. And the issue with third-party damage, this is the typical process safety Swiss cheese model, where you can say, well, actually you've got a number of activities that you're carrying out. None of those activities are going to control it properly. So you've got to apply a portfolio of activities, and you've got to recognise the strengths and weakness of each activity. Okay, this is just a more detailed assessment of surveillance. So aerial surveillance is the most typical surveillance technique, as we covered earlier on. It's very good at recording any encroachments or work that could affect the pipeline, and also any developments that are starting to occur. And the recommended frequency, in other words, all of the pipeline codes will tell you to carry that out every 2 weeks. Then you've got vantage point survey. That is exactly the same as aerial survey, because you do a vantage point survey when you can't do an aerial survey. So there may always be parts of a pipeline route that you can't actually carry out aerial surveillance over. In particular, if the pipeline's routed through an area where aircraft activity is limited, you may not be able to do aerial surveillance, so then you've got to do vantage point. Walking surveys. Typically, that would be risk-based, or probably once every 4 years. In some areas, every 4 years is not adequate. You really need to do them more frequently than that, because what you're looking at there is the condition of the markers, above ground crossings, pipeline cover, etc., which may depend on where the pipeline is. And then finally, we've got leakage surveys. Normally you would carry out some sort of leakage survey on a new pipeline just to check that any joints are actually made up properly. Older pipelines, if you've got components on them which could be the source of leakage, for example, pipeline sleeves, or sections of pipeline not inspected online or by overline surveys. So again, leakage survey is normally very much, operators will only do that based on a risk assessment. They'll say, if I do a leakage survey, am I actually going to pick anything up? And if I do pick anything up, where are the locations that's likely to happen, and I'll just survey those locations.
Excuse me. Why is walking survey done after 4 years? That's quite a long time.
It is, yeah, absolutely right. It is a long time. If the pipeline is in a remote area and that remote area is fairly stable, in other words, it's not subject to ground movement or anything which may cause the pipeline locally to move or actually remove the pipeline markers, then you could say, well, 4 years is probably okay. When you do the walking survey, what you're doing is looking at the condition of the pipeline right-of-way. Okay, so anything which could cause the pipeline right-of-way to change quickly will affect how frequently you do the survey. So if part of the pipeline right-of-way could regularly flood, then you should do the walking survey more frequently. In terms of things like markers, the markers have got to be there and they've got to be in good condition, because otherwise you're wasting your time getting somebody to fly over and do an aerial survey because they may not be looking at the right place. And landowners and occupiers often remove aerial survey posts or they damage them.
Okay, so and the information obtained from the area surveillance determine whether we should do the walking survey?
That's a very good point, and some operators do that. They'll basically say, right, okay, on this aerial survey, we're now starting to pick up a number of observations which need more interrogation, so we'll do a full walking survey of the pipeline.
And lastly, is it costly?
Walking survey. I suppose that depends on where you do it and what the resources would be. You could argue to do a walking survey you need 2 people, mainly because people shouldn't really be going out into remote locations and working on their own in case something happens. So you maybe need 2 people, and to do it properly, they've got to walk the full route at a reasonable pace, and they've got to record things while they're doing it. So it depends how much you're paying for your resources.
Regarding this walking survey, so I think this is like scheduled activity for the pipeline.
Most of them would be scheduled, yes.
The scheduled activity for your PM, preventive maintenance task. So this will be included in your program.
It should be, yes. Yeah, it should be.
But another leakage survey is like temporary.
Most of the leakage surveys are. So, for example, you might decide you're going to do a leakage survey if there's been some major event, like, for example, if there's been an earthquake or if there's been very severe storms, you might think, oh well, let's just go and do a leakage survey just to check. But in most cases, where you're dealing with fully welded pipelines, a full leakage survey will actually give you very little information.
Sorry, can you please explain the vantage point survey?
Right, a vantage point survey means, if you think about the purpose of survey, you've got to look everywhere along the pipeline route to actually see something. A vantage point survey means that you don't actually have to walk the route, but you've got to be somewhere where you can see it. So typically a vantage point survey, you would look at the route and you would say, well, at these locations along the route, if you put somebody there, they're going to be able to see that length of pipeline.
Something like a mountain hospital.
Yeah, yeah, yeah. Or in the UK, what you may do is say, well, most of the pipeline route that's important, you're going to be able to see from road crossings. And so you would send somebody out in a vehicle to do a vantage point survey where you wouldn't be expecting them to walk terribly far from their vehicle, but they should be able to see a reasonable length of the route. Okay. Right. Inspection of pipelines. This applies to crossings, internal inspection, external inspection, and is essential for corrosion control. And the requirements, if we look at the requirements for exposed crossings, the key issue here is security, mechanical defects, condition of supports, paintwork, wrap and guards. There's been a major issue in the UK with exposed crossings recently, mainly exposed crossings that go across waterways, because there's been a couple of fatalities where essentially kids have been playing on the crossing and then they end up falling in and drowning. So one of the key issues is if you have got an exposed crossing, you should really have something on the crossing to stop people getting access to it. Watercourse crossings, the issue here is the pipeline profile beneath the watercourse. In many cases, in recent pipelines, they've probably been bored under the water crossing, so there won't be an issue. But certainly for some older or seen as less important water crossings, they may just be laid on the bottom of the water crossing, so of course they can be subject to damage. And obviously, if they're on a riverbed, there's the possibility that the riverbed may change. These recommended frequencies here are essentially taken out of the pipeline codes. So internal inspection, your internal inspection really should be geared towards what damage you think the pipeline is going to see and what you want to detect. So very typically here you would a fingerprint inspection at the beginning of life might be required to identify any material defects which are in the pipeline, and also any construction defects such as dents or wrinkles which have been introduced. Then you do regular inspection looking for damage mechanisms which you've identified as being most significant. Most of the significant inspections will be metal loss, but obviously in some cases it might be cracking as well that you're looking for. And the internal inspection is generally based on a frequency. It's generally risk-based, so you look at the corrosion rate that you might be expecting. And if you don't do a risk-based assessment, generally the codes will tell you to do it at least every 10 years. And if you inspect every 10 years, in some cases, there might be things that you miss, so that in itself can be a bit of a risk. External inspection, this is to do with CP monitoring, SIPs, and I've got Pearson there, that should really be DCVG. So you're checking the performance of the corrosion protection along the length of the pipeline, and you're also checking for any open coating defects. And then corrosion control, essentially you're bringing these things together to confirm that you've got adequate control of corrosion throughout the length of the pipeline. Inline inspection, I'm not saying a lot about this. I know you cover inline inspection in another topic. The issue in terms of pipeline maintenance is you really should have a justification for selecting your inspection tool, and the tool that you use may vary throughout the life of the pipeline. So you may start at the start of life. You may want a full detailed geometric inspection so that you know where any construction dents or wrinkles are. Then you may say, well, I'm going to do regular inspection looking for metal loss, and then at some stage you might think, well, actually I just want to check in case I've got any cracking now, which may give me a fatigue problem. So the selection of inspection tools should vary with the pipeline and the life, and essentially what you're looking for. Right. Condition monitoring is particularly important where you've got non-piggable pipelines. You also need to use it, of course, for piggable pipelines, because the above ground survey, if you do it correctly, it will tell you whether the corrosion protection is applied properly throughout the length of the pipeline, and it will also tell you if you've got any open coating defects. You may have an open coating defect on the pipeline, and then you may inspect it and you might pick up no metal loss, but that open coating defect may result in significant corrosion that you then may pick up at your next inspection. So basically we're looking at SIPs to assess the corrosion protection system, and DCVG to assess the coating condition. I'm not going to try and explain that. I think it's in the notes if you're interested. But I'm not a corrosion specialist. But all I do know is these techniques are very important. And just a political point here. There's been a view, certainly a view in the UK, that techniques like these really are just like, magic wands, and they don't really give you a lot of detailed stuff. And the operators have pushed down the costs of doing these surveys so much that in the end you think, well, actually the surveys are not being carried out properly and they're not giving you any decent information. If you have got a problem with corrosion protection or the condition of your coating, and you've got a problem, operators will generally pay lots of money to get this done properly, so it is very important. But just because it's done regularly doesn't mean that what's done regularly is any good. And that applies to both SIPs and DCVG. In SIPs and DCVG, therefore, are very important, but you've got to bear in mind that they are subject to the location. So if you've, in some cases, in street locations or at road and rail crossings, and in particular, this is a big problem at the moment, electrical interference. Essentially, in where you've got particular problems, you may need to go to additional survey techniques such as electromagnetic current attenuation or long-range ultrasonics, which are both techniques that you can use not necessarily along the length of the pipeline, but at specific locations on the pipeline. And then that's just, there's a couple of explanations as to what these are. The accuracy of these techniques is very much dependent on the locations they're being applied at, and also the expertise of the people who are applying them. Okay, so a typical list of pipeline maintenance requirements. Marker posts which we've talked about. No recommended frequency, which basically means you should be monitoring them and you should be doing something about it when you don't have a typical, you don't have good coverage. And typically operators would say, well, if you've lost between 10 and 20% of your markers, you should really go out and do a proper upgrade. CP systems, typically they will be checked every month or possibly every 6 months if you're talking about sacrificial anode systems. Most pipeline CP systems, of course, will be impressed current. Pipeline sleeves, depends what sort of sleeves you've got and how good the sleeves are, which is why you would move from a set frequency to a risk-based frequency. Valves and valve actuators, very important and often what operators find, and if you look at the incident histories, in for example some of the incidents we talked about at the safety lecture, essentially valves are on pipelines to isolate sections when they need to be isolated. In general, you don't want to isolate sections of pipelines, so you don't worry about what the valves are like. The problem is if you ever do need to isolate and you've got a problem with the valve, you've then got if you can't use the valve to isolate, you've got a much bigger problem to manage. So typically they would be set at annual frequency or risk-based. And then pig traps. The issue here is mainly the seals, the door seals and the fastening mechanism of the doors. They're the major sources of safety failures that have occurred. But obviously pig traps are large pressure vessels, so they've got to be dealt with as large pressure vessels. And so typically they would be risk-based or once every 10 years. Risk-based would generally mean for a pig trap of when are you going to use it. You need to inspect and check it before you're going to use it. Then this list of threats to integrity. This list is taken from ASME B31 .s. So you can see, .8s. So you can see that that particular standard is a very extensive and comprehensive standard for managing integrity. Again, this is just an extension of the table that I showed you earlier. All right. Just thinking about inspection and maintenance optimization, you could say, well, inspection and maintenance optimization is really just another way of saying risk-based inspection, because normally what you would do is you would schedule your inspection and maintenance to make sure that the cost was minimum, but the information that you get from it allows you to actually act on the results. Okay, so again, background information is very important in this. But essentially, this is the logic that you're trying to apply. If you look at your inspection and maintenance costs, they will actually reduce if you extend the interval. Okay. However, if you think about this as being inspection, the longer you extend the inspection interval, the bigger the defect is likely to be when you do find it. And so if you now compare that with the repair costs, obviously repair costs are minimal until you get to defects which really need to be repaired, in which case they're high. So it's a balance here. You really need to get your inspection and maintenance costs down to be a minimum, but to make sure that when they are giving you results you've got to act on, you've got enough time to react, and the reaction is not going to cost you too much.
Sorry, question regarding this downtime. Previously,
Yeah, well, I mean, certainly in some cases, the downtime might be a cost. In other cases, it might not be a cost. It just might not be possible. So, for example, depending what the contractual arrangements you've got are for delivery of whatever, whether it's gas or aviation fuel or whatever, the contractual commitments that you've set up to might not allow you to have any downtime. So. Okay, that's just a very simple assessment of what sort of damage you might be dealing with in terms of what you need to look for and then what you need to do when you find it. In terms of external interference, you remember external interference is a random event. If it happens, you've got no choice about when you decide to inspect it. If you think you've had external interference, you've got to inspect it straight away, and the reason for that is that's the type of damage that's most likely to have occurred, most of which will be serious in terms of integrity. That's just another way of showing how the integrity threat could relate to repair methods. This is taken again from ASME B31.8s. And then this is just requirements for pipeline integrity management, in particular through the pipeline life cycle. The key thing to remember here is that the main integrity level of the pipeline is set at that stage. So you've designed it, you've built it, you've tested it, and whatever you've ended up with there, that's what you've got, and that's what you've got to operate and maintain going forward. Right, and then we've got a simple summary again of all of the inspection and maintenance activities and the frequencies associated with those activities, and then we've got the tutorial question. So I just want to make sure that you're comfortable with this sort of questioning and you would be happy to have a go at answering it. So the first one is saying you've got a liquid pipeline with intermediate block valves. It's saying what the pipeline design pressure is, which if it's high pressure, it doesn't really matter what the pressure is. It's routed through rural country, but it does have road and rail crossings. There are some planned developments and quarry works. The installation at the refinery includes a pump, a meter, emergency shutdown valve, a pig trap receiver, pig launcher, valves, and above ground pipe work. Describe the surveillance and maintenance requirements for this pipeline and the associated installations. Right. So if based on the way I've covered this topic, I'm going to always ask you, you're not going to have a pipeline that doesn't have anything else associated with it. So if you're going to maintain it, you're going to have to think about what it's got associated with it. An explanation of the surveillance method and frequency and the additional activities that may be required after surveillance. We covered that in the earlier lecture. If you get a sighting reported in surveillance, you've got to go and investigate it, and that investigation may mean you've got to go and see the landowner and get access and get them to do something to stop what they're doing. It might mean that you've got to go and supervise some work which is being done in the vicinity of the pipeline, or it might mean that you've got to do a risk assessment. List of activities to be carried out and their recommended frequencies, and in this case I've actually said time-based maintenance philosophy because most of the pipeline activities will be either time-based or risk-based. And if I ask you this question in an exam, I don't want you to say, 10 times risk-based. That won't get you any marks, right? Is that all right? Does anybody want to go through and talk about anything in more detail? Are you all happy? I've given you enough information to answer questions like that. Looks like we've got a 12 o'clock lecture in this room. Is everybody okay? Right, well, thank you for your attention, and I'll see you back here at 2 o'clock.
Yeah, and Helen said whatever, wherever you want to eat, wherever, I don't mind. It's just, yeah, sorry to bother you. And so is your email on the slides?
No, it's
Is
not.
it not? Okay.
Did you get Gary's email?
No, I didn't, no. But, and I wanted just to ask one more thing. In terms of when you mentioned the temperature, was you referring to the actual product or from an external perspective?
You normally, well, it's both you've got
Is
to
it both?
consider.
Okay.
But in reality, if you think about it, the pipeline wall temperature is going to be controlled. If it's not controlled by the fluid, it's going to be controlled by the ground temperature. So the ground temperature goes to the baseline, but the fluid temperature might tell you you're operating above that, which is going to give you a problem.
Yeah, okay.
Just like how Donald Trump hates China and hates
It's my voice.
Perfect.
I heard
Well done. Yes, I suppose we're having a meeting. I'm the one who Dr. Poo.
Sorry?
Dr. Poo scheduled the meeting.
Yeah, yes. Oh, you're the student who. Yes, I'm going there now.
Okay,
Yeah,
I'll be there.
Right.
Thank you.
Let's have a
Are you praying? Are you praying? What are you doing?
Yes, he's praying.
To pass exam, he's praying.
You don't need to pray to pass exams. You just need to
Study.
do the work. You just need to study and do the work. Absolutely.
Looks like these questions need extensive studying.
Well,
Like you need to have done extensive
Yes,
studying.
yeah. You certainly. I think I have had experience in the past where students come to my lectures and they think, "Oh, well,
Yeah.
that's just easy." But then they actually get the question, and because they haven't looked at the material, most of it is straightforward, but they haven't learnt it, so they.
So that is typically 20-mark question.
The examples I've shown you are typically half the question.
Half? Oh my goodness. So a full question carries 20 marks, right?
I think 25.
Oh, 25.
So every question has
Oh,
some questions,
25.
yeah?
Yeah. Oh yes. So, yes. And that's a university rule. You've got to break the question down into different parts, and you've got to show what the marking scheme is for each part, because obviously you've got to give people the best chance they can of answering the question, and they may not be able to answer all of it, but they may well be able to answer.
The one with the highest mark.
Sorry?
Like they may be able to answer the one with the highest mark if they see the guidelines.
Yes.
or something.
Yes. Absolutely. Yeah.
And the reason basically you break it down is to, if you give like a descriptive question and someone misfired and it was one block question, then they would miss all the rest.
Absolutely, yeah.
But then someone would have the chance to.
And it's heartbreaking. It does happen, and it's heartbreaking when it does, because you just think, well, they knew all of this information, but it isn't what's been asked for, you know. So it's,
And it's actually very easy for someone.
it is. It is. Yeah, because they have in their mind what they think is being requested, and yeah, it is. It is, which is why when you get to my age, you think, I'm not doing any more exams. I've had enough of that.
But to be honest, you know, we have a lot of things to read. So, like, we have almost the information that you've given us in 2 weeks. It is quite enormous, and we have to multiply that by almost 6 times.
Yes,
same
I know.
quantity.
Other courses.
And we have to do all those things. So
Yeah.
it's quite challenging.
It is quite challenging, which is that's why I've tried to give you an indication with the tutorial questions as to.
That's really helpful.
Yeah.
Yeah, because you know, to compress all that information and you're able to reproduce it in 3 hours.
I know.
3 hours? 2 hours? I'm going to have 3 hours.
I don't know. I'm not sure actually. I have a feeling that 2 hour. You'd need to check with past exam papers.
It would be less.
I think it's 4 questions in 2 hours. So really, you've got to do a question in 30 minutes.
Oh.
I'm sure that's what it is.
So when you said that we need to give straightforward answers, yeah, don't need to write many things.
As long as you're straight.
I'm not. I'm not asking for huge amounts. I mean, there are some of the questions are descriptive, so you've got to write.
Yeah.
But I'm not looking for essays or anything like that.
As long as someone gives a fact.
It's
and backs it up.
Yeah.
You should be able to get the marks.
Okay.
And then plus there are some things obviously that we need to understand to
Yes.
know.
Yeah.
But for examination purposes, I think there are some things we shouldn't, you know, like, because obviously we shall have to go through all this information for our own good.
Yeah.
But for examination purposes, we shall have to focus on some areas.
Yeah. Which I've tried to
Yeah.
give you some guidance on that. So.
Okay.
And I hope you find the exams fair and reasonable.
Okay, thank you.
Thanks a lot.
Anyway, as I say, we've got quite a busy afternoon because there's the assignment.
Yeah, and it's big as well.
Yeah.
Sorry, when's the deadline?
I don't know. I'll have to check with Narracon. I think it's the 27th of April. I think.
Plenty of time. You have plenty of time.
So you have. We'll talk about how you want to go about it this afternoon.
Okay.
I've read through yesterday. The pipeline should be changed from gas to SO2.
To CO2.
CO2. Yeah.
That's
so
right.
what we should consider there.
Yes.
So anyway, you will talk about it.
I'll talk about that this afternoon, and then
Okay.
then the second part of the afternoon is the lecture on Hottenstopper, which Gary Anderson has given you.
And it's quite interesting.
It is. He does a very good lecture. It's
Yeah.
very, very interesting. But I will cover next week specific bits that you need to think about for the exam.
Oh, so Gary will come after 3:30, you say?
He's coming at 3:30, but then I've got a session with you again next Friday morning.
Last Friday is going to be the last day of the lecture.
Yeah, of
Is it?
management, yeah.
Right,
But
okay.
we'll be wrapping it up.
Yeah. Yes, well, certainly from my point of view, it's the last session. I always say to students if there's anything in the material that I've done
So that
that
means
you
we
want
need to like study for next 2 Fridays so that we can come with lists of questions.
So yeah, I mean, if there's anything you want me to cover in any more detail at any point, then you just need to ask Narapol and you'll ask them to come in again.
Yeah, sure. So let's get to work next week. Bring this
Okay,
work.
I'll see you at 2 o'clock.
See you.
Thank you.
Maybe she should some tutorial questions there. So they might ask, she might ask those questions in exam, yeah?
Yeah, so it's like,
Yeah.
maybe not perfectly, but
Let me tell you.
But it's
You
not
know,
easy,
let
like
me
what's
tell you.
the surveillance is, it's not like this.
Listen,
She gives
I tried.
she
You know, I
said
don't like-
she never said
I don't
exactly.
like being so direct. Say, I'm going to set this in the exam, or but you saw the kind of questions I was asking.
Yeah.
And I was directing her to. Yeah. So
Is it
It's
funny?
recorded there.
It's recorded.